The learning target 1 is about piecewise functions. And a piecewise function is not that complicated. All it means is that for different intervals, there's a different piece of the function. So it's going to look complex if you look at it all together, but we're going to graph each piece individually, so it won't be that bad. All right? So try not to look at it all together. We're just going to do each piece separately. Okay? Now, all the pieces are going to be functions you've seen before. So possible things that might be are linear equations. They might be quadratic equations. They might be absolute value equations. All right? But there'll be things that you've seen before that you can graph. At the very least, you can graph them with the assistance of making a table. All right? But you'll be able to figure it out.
Okay.
Okay. So here's the first example. And it says f of x equals 2x if x is between 0 and 4, and 8 if x is between 4 and 7. Now, there's a lot of things I'm assuming you know from other algebra classes, other math classes. But A, you know how to graph lines, generally. B, you know what these inequality symbols mean, and know which ones are associated with open and closed circles. I'm assuming you know how to make a table if you need to in order to graph a line or anything. So I'm going to be doing a bunch of those things. If you're confused about what I'm doing, just make sure you ask questions. I'm assuming you know them, but if you get lost, just let me know. All right, so in this first function, there's two pieces. All right, so we're going to do one piece at a time. So the first piece says 2x if x is between 0 and 4. So I'm going to ignore the rest of it. I'm just going to graph this first piece. When you're graphing these, it's giving you a very specific place to graph them. It says from between 0 and 4. All right, that's very important. You always have to graph the endpoints of your interval. In this case, I need to graph whatever coordinate is happening at 0 and whatever is happening at 4. Okay? Now, y equals 2x, which is all this is. Y equals 2x. What kind of graph does that make? What does it look like?
That's 2 over 1.
What does it look like, though? It's a straight line. Right? So because I know it's a straight line, all I really need is 2 points to graph it, right? So I can graph what's happening at the endpoints, and then I just know there's a line in between. If it happened to be a quadratic, you can't always do that, because you might have the minimum or maximum point in the middle, and it curves, and so you might have to do some more points in between. In this case, we only have to focus on the endpoints, because it's a straight line. Okay? So for all of these, I'm always going to at least show information on the table. You don't have to use a table, but I'm always going to show it so that everyone's on the same page and knows where I'm getting these values from. So if I'm going to graph this first piece, then I'm going to use 0 and 4 as my x values. Then I'm going to put that into the function to figure out what the y value is. Again, you could do that in your head, and that's okay. So what's 2 times 0? And what's 2 times 4? So I have a point at both of these places. Those are my endpoints. If you look at your inequality symbols, they're both less than or equal to, so they're both can be closed circles. That's important as well. So 0, 0, and 4, 8. And we know it's a line because y equals 2x is a line, so we're going to draw a line between them. Yes. It needs to be as straight as you can. You don't have to have like a straight edge, but don't make it look like it's some curly cue. Questions about how I got that or where it came from?
If it wasn't like supposed to be closed, would it be dotted lines?
The line would still be a line, but the endpoint would be an open circle.
Okay.
Correct. We're going to do that on the next problem. Okay. Is everyone okay with the first part of the graph? There's nothing else to do. We graphed what it's supposed to look like from 0 to 4. We're done with that part. You could ignore it for now. Okay, and we'll graph the second piece. So the second piece says f of x equals 8 from 4 to 7. So what does the equation y equals 8 look like? Horizontal line, right? The horizontal line at 8. Again, we have to make sure we include the endpoint. Okay? So again, I'm going to use a table. You don't have to use a table. My endpoints are 4 and 7. So at 4, y would be 8, and at 7, y would be 8 because it says y equals 8. And everything between would be 8. Okay? I'm not. The equation says y equals 8, so there's not a place to input an x.
Okay.
It just means for every x value, y is 8.
Okay.
So,
Oh, I got it now.
because it says x is between 4 and 7. So we're using the endpoints 4 and 7, but 5.5, 6, whatever is between 4 and 7 can be x value. Now, it says that 4, we have an open circle, right, at the 0.48. But there's already a closed circle at the 0.48. That's okay. This connects, right? And we're going to talk in a second about why it's important that this part was open, right? But we're going to leave it closed. You don't need to make a circle around the closed circle or anything. We just leave it closed, okay? Then we make our other point at 7, 8. And that one is closed because it says less than or equal to. And we draw a line between there. Not too bad. Any questions about where the actual, that is the graph. Any questions about where the actual graph came from? We did each piece individually. Then we're going to talk about some extra questions. But yes, that's the graph. That is it. Questions? All right, so there are some other alternate questions that might be asked of you. There's 3 different things that could be asked of you. 1, maybe they ask you, is this a function? If you're trying to figure out something's a function, you always use the vertical line test, right?
Yes.
Vertical line test means you draw a vertical line, you should only hit 1 point at a time. This is why it was very important that on this part we had a closed circle at 4, 8, and this part we had an open circle at 4, 8, right? That means that technically the 2 pieces don't overlap. There's not 2 points in the same place. Does that make sense? We only hit 1 point because one was closed and one was open. So that means this is a function, right? Because every time you drew a vertical line, you'd only hit 1 place on the graph. If they were both closed, that 0.48, they were both closed, then you'd have a piece that overlaps, okay? And that would be an issue. Questions about how to tell if it's a function or not? Okay. They might ask you about the domain in range. The domain, by definition, we'll get into this later this week too, but the domain by definition is all of the possible x values. All right? So you look at the x-axis and the x-axis only, and then you think about what is what x values are being used. All right? So what's the smallest x value being used? And what's the largest x value being used? 7. So my domain, you can write it a few different ways. You can write from 0 to 7. Make sure that your inequality symbols are including your values, and you make sure you use x. We're talking about x values. I think Mr. Scott did set notation with you. So you could write 0 to 7. You would use brackets because they're both included. Right? But you can't say all real numbers because it's not all real numbers. It's just 0 to 7. Questions about the domain? They'll then ask you about the range if they ask you about the domain. So the range, you just look at the y-axis, all right? What's the smallest y value being used? And what's the largest y value being used? So again, you have 0 to 8. Again, those are both included, so make sure you say so. You could use set notation. You want to use brackets here because they're included. There's a question on your final that I gave to you on the pre-test in this class, and it was also on the first unit test in this class, and it asked about domain and range. And a lot of you guys would have gotten it correct both times if you had taken the time to look at the choices. Half of the choices used x, and half the choices used y, and asked specifically about the range. If it's asking you about the range, what variable has to be used?
Y.
Y. But half of you guys put an answer with an x in it. That can't happen. I practically just gave you the answer to one of the final questions. Just make sure you keep paying attention. Okay? Questions about domain or range for this question? They might ask you about that. All right. and then the last thing they might do is they might ask you about function notation, and I'm going to do that up here. I'm going to shade the graph too. You don't need the graph to answer questions involving function notation. All right. As a review, really quickly, so everyone knows what I'm talking about. Function notation is like when you say f of x equals 2x plus 5, and then I say, well, what is f of 3? And what is f of negative 2? That just means put 3 and negative 2 in for x, right, and give me what y equals. So 2 times 3 is 6, and 6 plus 5 is 11. 2 times negative 2 is negative 4, and negative 4 plus 5 is 1. Right, that's function notation. Everyone understands what I mean when I say function notation.
Yeah.
When you're doing piecewise values and you're doing function notation, you have to make sure you're in the right interval so you know which part of the function to use. All right, that's the only thing that's different. So for example, if I said find f of 3, is 3 in the top interval or the bottom interval? Top. 3 is between 0 and 4. Right? So I would use 2x as my function. So what's 2 times 3? So the answer would be 6. Questions about that? If I asked you, what is f of 6? Does 6 fall in the first interval or the second interval? The second. It's between 4 and 7. So if number x is between 4 and 7, then y equals 8. So the answer is just 8. There's nothing to plug in because it just said y equals 8.
What's that for? The size of what?
It just says, like, if it's going to give you function notation values, you have to find them. If it said to find f of negative 2, is negative 2 in one of these intervals? No. We even saw the graph earlier. Was anything happening over here at negative 2? No. So the answer just does not exist. There is, like, the graph isn't over there. There are no points over there. So you don't, like, make up an answer. There's no answer. Questions about that? There's some of the homework questions are in the textbook, and they just ask you to graph them, and then some of them are on a worksheet, and then ask you some of these questions. Like, what's the domain? Is it a function? Function notation questions. All right? Any questions about the first example? Any at all? Then let's do the second one. I'm going to do the top piece and the bottom piece first because they're easier. Y equals 6 if x is less than or equal to negative 6. All right? So again, what does the line y equals 6 look like if you were just visualizing it? It's a horizontal line at 6, right? So again, if you need to use a table, you can. You always need to use the endpoint. So negative 6, less than negative 6 would be like negative 8. But at those two values, negative 6 and negative 8, you have 6 because y equals 6 there. So if you graph this, do you have an open or closed circle at negative 6, 6? Closed. And then it just says for all values less than or equal to negative 6. So that means this line is going to continue forever towards negative infinity. So make sure you include an arrow. That arrow is important. That means it doesn't stop. Otherwise, you'd have to show the endpoint. Yeah. Questions about how I got that piece? Negative 6, 6. Yeah. I know, right? On this other piece down here at the bottom, it says y equals 6 if x is greater than 6. So still the same line, just different interval. So this only happens at 6 and above. So 6, 7, 8, right? Notice I still use 6. I know it doesn't say equal to, but you still use the numbers as the endpoint. Okay? So at 6, we get 6. At 7, we get 6, yada, yada. right? So we're going to graph that. We put a point at 6, 6. Is it open or close? Open. And then we make sure we include our line that continues until infinity. So the arrow is there, and that's important. Questions about those two pieces? I haven't done the middle piece yet. The questions about those two pieces. All right, the one in the middle then. Absolute value of x, if x is between -6 and 6, right? What does the graph of the absolute value of x look like? What does an absolute value graph look like? What shape does it make?
A V.
It makes a V. If you aren't sure of that, then you need to make sure you include a variety of values in between -6 and 6 so you know what shape it makes, right? You know it doesn't make a straight line, so you need to make sure that you put in some values, negative and positive, so you know what the shape is going to be, all right? So if you weren't sure, you would be start at -6 and then do some other values all up to 6, because it's -6 to 6, okay? If you know it's a V, then you really only need 3 points. You need the 2 endpoints and then where it's going to change over the bottom of the V, which would be at 0, because it's in the middle.
Is it after those numbers?
No, just to do numbers between -6 and 6. But you have to include the -6 and the 6 because you have to have the endpoints. Okay. So what's the absolute value of -6? And what's the absolute value of -2? 2. And then 2 and 6, right? So you graph these points. We have open circles at both ends, right? There's already a point at -6, 6. And it's open. That's okay, right? That just means we don't have overlaps. If they ask about being a function or not, we know there's not 2 points at the same place. We have a point at -2, 2, 0, 0. Again, you could have used different points. Then 6, 6 is also open. And there's already an open circle, so we're going to leave it open. Okay? And we just connect those. Questions about where that came from? Those are just points on the line. It's only open at the endpoints. Everything in between is just part of the function. So we're not doing inequalities where we have dashed and dotted lines. Just open and closed endpoints. Okay? Because it said the absolute value of it. Brandon, you could be a little more sensitive. Okay. So, is this a function? If you use a vertical line test, do you ever hit anywhere where it overlaps? So is this a function? It is a function, yes. Right, that closed circle at -6, 6 isn't 2 separate points, it's just 1 point, one was closed, one was open. All right? There's a hole at 6, 6. That's okay. As long as we don't overlap 2 places, it's still a function. So this is a function. If I was talking about the domain, what would be the domain of this function? What are the possible x values?
All real numbers.
Almost. Except for 6.
Yeah.
Right, it goes from -infinity all the way to infinity, right? So all the x's are being used, except there's a hole right here, right? So you can write all real numbers except 6. If you're going to use set notation like Mr. Scott did, you would have from -infinity to 6 with parentheses, right? Because you don't ever include infinity. Correct, it's not bounded. And then we're not including the 6, so we want to make sure that it's a parentheses. And then we would need to go from 6 to infinity, right? Either way to write, this is both correct ways to write this. Okay, I don't care. As long as you make sure you show me that it's all values except for 6. What about the range? What are the possible y values? What's the lowest y value used? 0. And what's the largest y value used? So 0 to 6 or 0 to 6, whichever.
Wait,
Yes.
on the B,
The domain.
yeah, why is it a B?
It's an intersection. It just looked like a V. It is. Mine just turned into a V because I was writing it quickly.
I can't remember. Does it matter? It's like upside down or
It might not here because you want both, right? You have to have both pieces of that to be the entire domain. That means and. It's the intersection. If you wrote or, it wouldn't be wrong, probably. Wouldn't. In fact, that might be wrong. I have to think about it. Because it can't be both of those at the same time. I'm just thinking that I use these in statistics for different reasons, so I'm just writing and.
Would you rather us just do the top one instead of messing with all that?
It doesn't matter. I would write it the top way, but I know that Mr. Scott told you the other way, so.
But either way,
Yeah. Yep. Questions about graphing them? For now, I've got two pieces of information that I'll make sure that I conveyed to you for the homework. One is you always indicate the endpoints. Always. Always. So let's say one of the intervals said x is less than 7. You still plug 7 into the function. And you just have an open circle there. You don't like, since it says less than 7, that you don't use 7. You always use the endpoints. Always. Okay? Like on this one we did just now, and these, it said less than, but we still used them. Okay? So I had people earlier today that said, well, it said less than 6, so I used 5. You still have to use the endpoints. Because I don't even know what happens all the way up until that point. Because x could be 5.87, right? So you have to go all the way to the endpoints and then not include them. You can't just like skip over some numbers. Also, if you're in doubt of how to graph something, use a table. So if you weren't sure how to do that absolute value function, just make a table. It's not a big deal. On some of the homework questions, you have like x squared plus 2x plus 1. And it says for x greater than negative 1. Okay? Well then, use a table. I know that you guys have learned how to graph quadratic equations, and you could like have the vertex and the axis of symmetry and all that jazz. But if you don't know how to do all that at the moment, that's fine. Just make a table and it'll be okay. I'm not judging you because you made a table. So we would have x greater than negative 1. So negative 1, 0, 1, 2, I don't know, use some values, right? Common mistake on your last test, people were squaring negative numbers and getting a negative number, which was messing up their algebra. So just keep that in mind. Make sure you're using parentheses if you're using a calculator. So negative 1 squared is 1. Plus 2 times negative 1 is negative 2. So 1 plus negative 2 is negative 1. Plus 1 is 0. 0 plus 0 plus 1 is 1. 1 plus 2 is 3 plus 1 is 4. 2 squared is 4 plus another 4 is 8 plus 1 is 9. Right? You guys can use a table and then graph the points. Like I'm just saying that's totally fine. Questions so far about this concept? We're going to practice all day tomorrow too, but questions so far? All right, I've got one more example then, the one at the bottom. Here we have a piecewise, and we have to write the equation for it. Okay, it's already graphed. We're going to write the equation. So, it doesn't really matter how you approach this. You just have two different pieces, right? This one? No. Sorry. All right. Let's look at this piece first. Generally, you go from the smallest x to the largest. So we're going to start farthest left on the graph and then go to the largest. Doesn't really matter, but that's how it's normally done. This is a linear equation, right?
Hey, yes.
This is a linear equation, yes. So the easiest thing to do first is define the interval and then go back and write the equation for it. So between what x's is that part of the function following? What x values?
Less than -2.
Right, less than -2. That's it. Right, it's going to, and there's an arrow, it's going to negative infinity. Right? So if you're looking just at the x-axis, which is what we're looking at, then the interval will be from -2 and then lower than that. Right? So x less than -2. Is it less than or equal to?
Less than.
Right. X less than -2. Is everyone okay with where I got that from? All right. Looking at the function, we have to write the actual equation. If you want to write a linear equation, what two things do you need?
Slope.
Slope is one.
And y-intercept.
Y-intercept is the other. All right, so we can figure out the slope because of a graph. We can just count. We can do that. No big deal. The y-intercept is not part of our actual piece, but once we know the slope, couldn't we count back up and find where it would have been?
Yeah.
Yes, so we're going to do that.
Yeah.
I know that this graph is not awesome, but it's like because the line is off a bit. There's a point here, here, and here, and there's a point here.
One.
Right, so if you're looking at rise over run, you go up 1 over 1. Right, it's going in the positive direction, so make sure it's positive. So we have 1x, or just x. If we continued the slope, and we wanted to find where it crossed the y-axis, up 1 over 1, up 1 over 1, up 1 over 1. What is this y-intercept?
5.
5. So you have 1x plus 5. Again, I know that's not part of the graph, but that is part of the equation. So you need to make sure you have the y-intercept. Okay? If you just wrote 1x without the plus 5, that's not actually the graph of that line. All right, you wouldn't end up with the same picture. Everyone clear on the first piece?
What was the slope in black? What's in black? Like the.
X less than -2?
Yeah.
That's the interval this happens on. This is still just mx plus b. Slope, y-intercept. All right, the second piece. Again, I think it's easier to go ahead and get the interval out of the way. What is the interval for this piece? From where to where, or to what to infinity, or whatever? -2 to positive infinity, right? So it would be all x. Is it greater than or equal to? Greater or equal to? -2. Right, from -2 on is where that falls. Okay. What is this equation? It's a straight horizontal line. Then y equals what? -2. So that is our equation for this graph. Does that make sense?
Yeah.
Maybe. Enough to practice?